Hello, welcome to this event in Glasgow at the Nordic Pavilion during COP26. My name is Dr. Carol Turley. I'm from Plymouth Marine Laboratory and I will be moderating this event. The event is on something completely different. It's ocean acidification in the Northeast Atlantic, the Arctic and the Baltic waters. And this is another reason, very good reason, for an enhanced ambition for urgent CO2 emissions, because it's the other CO2 problem. Ocean acidification is caused by the ocean uptake of nearly 30% of the CO2 emissions that we've carried out to date. It's impacting ocean chemistry, ecosystems, fisheries, and dependent societies. And this event is a sort of state of the nation's waters update. And we have high-level speakers, science experts, who will discuss the issue of ocean acidification and how this could improve and increase the drive towards achieving the Paris Agreement. So this will be very much an interactive discussion. There will be no PowerPoints. I know it's unusual for scientists, but we're going into our non-comfort zone here. We have a high-level ministerial speaker and we have the experts, and I'm also very, very happy to welcome the youth delegate also to speak. So to the panelists. We have the high-level speaker, Minister Gudbrandsson, who's the Minister for Environment and Natural Resources in Iceland, and he will be joining virtually. Here he is. Hello, Minister. Welcome. We have Peter Haugen. Peter, welcome. Peter is the former chair of UNESCO's Intergovernmental Oceanographic Commission and the former vice chair of the European Marine Board and is program director of the Institute of Marine Research in Norway. And he will be appearing virtually. Could we have our speakers back up, please? Yes, thank you. Now, non-virtually, in person, we have Richard Bellaby. He's research coordinator at the Norwegian Institute for Water Research, and he's director of the Center of Marine and Coastal Climate Research in State Key Laboratory for Estuarine and Coastal Research at the East China Normal University. Thank you, Peter. So, Peter stretches the world. Next, we have Helen Finlay, also appearing in person. Helen's from my own laboratory, Plymouth Marine Laboratory, and she's a researcher there, but she's also chair of the Global Ocean Acidification Observing Network, GOAN, the hub for the Northeast Atlantic. So that's very relevant. Just outside, a little trip out there, you reach the Northeast Atlantic. And then we have Melissa Shiritsi. Melissa, hello. She's here. Melissa is at the Institute of Marine Research Bergen and the University Centre in Svalbard, Norway. And she's co-chair of the Global Ocean Acidification Observing Network, GOAN. You're getting there, GOAN. It's Arctic hub. So that's really important up there at the top of the world, the cold bit, and you'll hear more about that later. Also joining virtually is Natalia Gallo. She's at the University of Bergen and the Vietnamese Center for Climate Research, and she's a member of the UN Ocean Decade Early Career Ocean Professionals. and she's in Norway. Hello, Natalia. And also appearing virtually is Marco. Hello, Marco. Marco Reinikainen is at the Air Pollution and Climate Secretariat in Sweden, and he was program leader of the Baltic Ocean Acidification program. And finally, and not least, is Emma Turkey, who's a master's student in nature management at Copenhagen University, and she's a member of the Danish youth delegation. So welcome everybody. We're right on time, so I would like to welcome the minister from Iceland, Minister Gudbrandsson. I hope I've pronounced that properly. I'm sure you'll correct me. Minister, we welcome your intervention. Thank you.
Yeah, thank you so much, and good morning, Glasgow. It's lovely to be able to be with you virtually. And let me first begin by thanking you for organizing this event. It's important, in my view, to turn the spotlight on ocean acidification. Now, we know that many impacts of climate change are highly visible. We could take the example of glaciers in Iceland, which actually have become icons of climate change. The outlets of our big ice fields are receding fast. Our smaller glaciers are vanishing altogether, as we can see. We even had the funeral for one of them 2 or 3 years ago. If you go to the Vatnajökull National Park, you can see climate change in action. You can walk to the edges of glacier tongues, and you can see sort of posts that have been put down along the way where they were located in the past years. So you can follow how much they actually have receded. And in a century or two, there may be little or no ice left in Iceland. So then it's a question, what do we do with the name of our country? Well, anyways, that really should alarm us. That is my message here. But other changes, they are more subtle and invisible. That doesn't mean that they are less important. This goes for the ocean in many cases. The ocean covers 70% of the planet Earth, and our carbon emissions are bringing about profound changes there as well. And these changes in the sea will affect humanity in many direct and indirect ways, as we know. Increasing sea levels threaten millions of people in small island states and low-lying areas around the globe. Changing ocean currents can disrupt the climate, and so will the rapid retreat of Arctic sea ice. And then ocean acidification is perhaps a more subtle threat. Perhaps we could say that it is a silent, invisible killer, hiding in slow but steady chemical changes as the sea tries to absorb the CO2 that we pump into the atmosphere. It is a threat to marine life everywhere, most obviously to organisms like corals, shellfish, crabs, and many forms of plankton, but ultimately it will affect the marine ecosystem as a whole. Past events of acidification have left a history of devastation in the fossil record. There is still a lot we do not know, but there is certainly every reason for grief, concern. Some of the most rapid acidification recorded anywhere occurs in the sea north of Iceland. It is here that the surface waters cools down and sinks on their northbound journey, one of the key turns of the so-called global conveyor belt, a vast system of ocean currents that snakes around our watery globe. With a little bit of simplification, you can say that this is an end station for a big branch of the Gulf Stream, where it takes a downward dip and reverses its flow in the depths below. This is a prime sink for the carbon from the atmosphere, without which global warming would be even more rapid than it is. But there is a price to be paid for the service that the oceans provide. Deep down, acidification creates an area where aragonite saturation is reached, if I may be so bold to use the jargon of science. What it means is that there is a death zone for shellfish and many organisms, and it is spreading. Make no mistake, this is the problem of humankind, as well as many others related to climate change. Scientists predict that the disruptions of ocean acidification can affect cod and other important fish stocks in the North Atlantic later this century. There is real possibility that coral reefs everywhere, often called the rainforest of the sea, may go extinct within 100 years. So spare a thought for deep sea shells and other creatures of the deep. They are sounding an alarm, and we need to listen. Our knowledge of ocean acidification is incomplete. 2 years ago, I signed an agreement with the Icelandic Marine Research Institute on increasing research on the impact of acidification on the ecosystems in Icelandic waters. In my opinion, this is very important. Science and knowledge are the foundation of our policies and actions to counter the climate crisis. It is therefore great to see here a panel of experts that can help us to get a good picture of the latest science. And I thank you all for doing that. Perhaps nowhere is our gap in climate change knowledge greater than in the case of our oceans, and we need to close that gap. We know enough to know that we need to act faster than we are doing. We need to preserve hotspots of biodiversity in the oceans, but there is a limit to this approach. No marine protected area or other such measures will halt the impact of a global increase in ocean acidification. By all means, let's explore every opportunity for adaptation, but that should not distract us from the pressing and most important task at hand, which is cutting emissions. Only by cutting carbon emissions can we stop the silent killer of sea life, ocean acidification. Only by delivering on the Paris Agreement can we stop a global threat against marine ecosystems. I laud the efforts that you have made to bring this important issue to our attention. And this is a story that needs to be told and brought to the world's attention. I'm really looking forward to the panel, but I will stop here for now. And thank you, Carol.
Thank you very much, Minister. Do you know, Iceland has one of the longest observations for ocean acidification in an area that is so very important. So I'm really heartened to hear that you've extended funding to the Marine Centre in Iceland. And the vision of the scientists early on, 20 plus years ago, of actually starting that observation series is truly well leading. So I'm very impressed. I had the pleasure of visiting them about 2 years ago. Thank you. Anyway, we have some wonderful questions here for the panel. Now to Peter first. Peter, could you just explain to those that don't know what ocean acidification is and whether it is a global issue? Thank you.
Thank you very much, Carol. Thank you for running this, and thanks to all the organizers. This is really a crucial, important issue that needs to be highlighted more. And in fact, I'm also impressed by the former speaker, the minister, who explained about ocean acidification. Yes. And the science policy interface is so important for this particular issue. It is the second CO2 problem. I think that wording was already used. The first CO2 problem is, of course, the global warming that we can see in many aspects, also in the ocean. But the second one that deals directly with the impacts of increased atmospheric CO2 is ocean acidification, and it's much more difficult to get a feeling for, to get the public to be aware of, as also the minister explained. So wherever we increase the atmospheric concentration of CO2 and that atmosphere is in contact with water, we will have carbon into the ocean, and we will have ocean acidification. And so the increase in inorganic carbon concentration and the various chemical changes that occurs, that I will not go into here, but which then is expressed as a reduction in the pH level, not making the ocean really acidic, but making it more acidic than elsewhere. And I would like to start maybe with some personal reflection. Back in the 90s, 96, 25 years ago, I wrote my first paper on ocean acidification. And that was motivated not so much by this atmospheric increase. It was a way to make people aware of it, because what people were aware of at that time was efforts towards removing CO2 from power plants and disposing them maybe in the water or below the seabed. And people were afraid, rightfully, for leakages and big high CO2 concentrations and then impacts of that in local waters. But we felt it necessary to make people aware of also this second CO2 problem, which doesn't only occur locally, but occurs globally whenever we increase the atmospheric CO2 concentration. It's a bigger problem. There was an initiative from, you mentioned, Intergovernmental Oceanographic Commission, the Scientific Committee on Oceanic Research, the science and the policy came together. The first The Ocean in a High CO2 World Conference was hosted in 2004 and has been going on since then. But I think still there is a very big need to improve the knowledge and understanding of this difficult problem. It doesn't help with geoengineering in the type of solar radiation management if we are to avoid this ocean acidification. By those kind of things, you can perhaps avoid some of the warming. You cannot avoid ocean acidification in any other way than reducing the CO2 emissions to the atmosphere. And that's something we need to press on and on in every fora. The UN Decade of Ocean Science for Sustainable Development, ocean literacy, the kind of events you're running here, is so crucial. And that's why I'm so happy to be here. And I give the word back to you, Carol. I'd like to follow this discussion on. Let's keep the pressure on informing about ocean acidification. Thank you.
Absolutely. Thank you very much, Peter. We will come back to you with the further questions later. But moving on, next to Helen. How is ocean acidification progressing in the region you are studying, North East Atlantic? And how will it develop if we don't increase ambition on CO2 emissions reduction to meet the Paris Agreement?
Thank you, Carol, and thank you for inviting me to be part of this panel today. So I work on the North East Atlantic region, as do many of my colleagues here. The North East Atlantic region covers a very different array of oceanographic conditions, ranging from the formation of the deep waters in the Icelandic and the Arctic waters pouring down into the top of the Northeast Atlantic, right down to the coastal waters around the North Sea and the influence from the Baltic, which we will hear about. So overall what we can see is that the observations are showing us that there is a decline in the ocean pH in the surface water and in the deep water layers as well. And we're expecting to see that decline continue throughout the next century and beyond, depending on the emission scenarios we use. Because there's such differences across the Northeast Atlantic, depending on where we look, rates are different. So, for example, around the North Sea, what we actually see is higher rates of ocean acidification because of the different local factors that influence that overall global anthropogenic CO2 emissions. So, for example, in the North Sea, we have a lot of freshwater influence, and that freshwater adds lower pH water in its own right. We also have very differences in terms of the surface waters and the bottom waters. And so in the bottom waters, actually, we see a lot of remineralization, so production of CO2 by bacteria and consumption of the phytoplankton material, which actually adds to that carbon dioxide and adds to that issue of overall global ocean acidification. For future projections, if we follow the mid to high emission scenarios, we expect to see the waters continue to acidify by about 0.3 of a unit of pH. And in terms of aragonite saturation state, which is essentially a measure of how corrosive the minerals are to organisms that rely on calcium carbonate shells and skeletons and corals, that saturation state is decreasing as well. And in particular in the North Sea and surrounding areas, we expect to see seasonally high-frequency events of corrosive waters becoming more frequent and covering a wider extent. If we follow the lower emissions pathways, we can minimize the extent of those and minimize the frequency that we experience those events to maybe just once a season or once a year.
Can I just ask so I can understand it? Corrosive waters, what does that mean? just for us who are not ocean experts?
Sure, so alongside the decline in ocean pH, the change in ocean chemistry results in a reduction in carbonate ion concentration. Carbonate ions are important for joining together with calcium to make calcium carbonate minerals.
Okay.
If you reduce the amount of carbonate ions in the surface water, the calcium carbonate wants to give away its minerals and essentially corrodes or dissolves away. So if you have an exposed lump of chalk or an exposed shell or coral structure, that will give up, it will essentially dissolve or in that corrosive water. Now, we're not talking about reaching those immediately, but if we continue on pathways down into the future, we could be getting to that state. We do have to remember organisms are alive, so they've got mechanisms to deal with that, but if they were just exposed material, then they would be facing that corrosive water.
Thank you. Thank you. Thank you, Helen. It's the same question to Melissa. How is the Arctic doing?
Yes, thank you, Carol, and thank you, all of you, for having me here in this panel. And yes, so as you might know, also the Arctic has had drawn lots of attention with regard to ocean acidification, since it already has a very low carbonate ion, as Helen now explained, and low pH situation because of the meltwater and freshwater that is highly influencing the Arctic areas. And in addition to the chemical state, which is not very favorable for ocean acidification in a way, you also have the anthropogenic CO2 coming in from the Atlantic water inflow. So you have most of the uptake is occurring in these deep water formation areas that the Icelandic minister and Helen was talking about. Most of the uptake is occurring outside the Arctic, but actually bringing in lots of anthropogenic CO2 into the Arctic. So, and also we haven't been fortunate with having this long time observatories that you can see in some other parts of the ocean. However, some of the research cruises from many years, so now we actually, I would say, start to actually see and be able to quantify trends of decreasing pH and aragonite saturation in the Arctic. And you can see evidence from the Western Arctic, where you also have a spread and increased volume of this corrosive water, if I may use that word. That means that you have a higher volume of water which is spreading northwards and also going up to the surface. In the Eastern Eurasian part, we also see decreasing the pH and aragonite saturation, which is mainly confined to the Arctic part of the water, the Arctic water mass, this cold and typically Arctic water mass, which is formed in the Arctic. But we also, the main cause for these changes that we see is accumulation of the anthropogenic CO2 from the Atlantic water, as well as internal processes within the Arctic that is enhancing the ocean acidification. And some of those processes we will talk about later as well. But anyway, yes, we see ocean acidification process. So it's not only modeled, which it was when we started discussing that the Arctic Ocean was the most vulnerable for ocean acidification. Now we actually have observational evidence showing that it goes at a faster rate than other open oceans. I can stop with that.
Thank you very much, Melissa. That was perfect. It's really worrying for ocean acidification in Arctic waters, and I think we'll return to that later. But now, going from the two big oceans that surround our shores, the Arctic and the Atlantic, we're moving in to more local and regional things. So the first one will be on fjords, and this will be by Natalia. Take it away, Natalia.
Thank you. It's a real pleasure to be here with you virtually. I'm joining from Bergen, which is on the west coast of Norway, and it's sometimes called the gateway to the fjords. And fjords are the ecosystems that I focus on in my research at the University of Bergen. Fjords were carved into the landscape by the retreat of glaciers and are the fingerprints of past climate change on our coastlines. These deep crevices were filled by the ocean and now host productive and diverse marine communities and are economically important for aquaculture activities. However, there are problems lurking below the surface, and one of these is rapid ocean acidification. However, the acidification process is different than the one that we often hear about at the ocean surface, and instead here the ocean acidification occurs due to a stagnation of water exchange. Many of these fjords have shallow sills that separate the deep water basins, and in order for the deep basins to receive new water from the coast, the water column has to have specific physical properties. Climate change has affected the system, leading to longer periods of time between renewals of fjord basin water. In addition, aquaculture also contributes excess nutrients to the system. Due to both climate change and aquaculture, oxygen levels in the basin waters are decreasing, and then through the process of breathing of microbes and animals, these deep waters also accumulate carbon dioxide, leading to acidification. One of the fjords we focus on is called Moss Fjord. It's about 6 hours north of Bergen by ship. And between 2011 and 2018, Moss Fjord lost about 67% of its dissolved oxygen in the basin water. We estimated that corresponding to this decline in oxygen, basin water pH declined from about 7.82 to 7.53, or a decrease of almost 0.3 pH units during a period of only 7 years. In contrast, the global surface ocean is not expected to experience a 0.3 pH unit decrease until after 2050, and only under the worst climate scenarios. Consequently, the acidification I am talking about in these deep fjord waters is very rapid compared to what is occurring at the sea surface. One positive is that this change does not have to be permanent. When the fjord basin water is renewed, oxygen and pH both increase, as has just happened early in the summer this year in Moss Fjord. These rapid changes in pH and oxygen allow us to examine how deep-sea marine communities respond to acidification and deoxygenation, and which species are most vulnerable. We currently have 3 ongoing projects examining the changes taking place in the fjords, and these also include measurements of changes in acidification. These bring together colleagues from the University of Bergen, the Bjerknes Center for Climate Research, and the Institute of Marine Research, as well as international colleagues. And these projects will allow us to understand the consequences of climate change for these iconic ecosystems. If we don't increase ambition on CO2 emissions reductions, then these fjords will continue experiencing longer periods of time between renewal events, leading to acute acidification and hypoxia. And also certain fjords may reach tipping points and stagnate permanently.
Thank you, Natalia. Perfect and to time. Well, I mean, we're really hearing about hotspots of acidification now. We're hearing about how the whole oceans are being impacted, but how regional and local hotspots are also occurring. And these are close to land, close to us, close to our fisheries and aquaculture. Now, we have an inland sea, and we'll be turning to that now. Marco, how is the state of the Baltic Sea, please?
Yes, thank you. I'll try to answer on that. So the Baltic Sea has a defining characteristic which makes its ecosystem sensitive to environmental threats. This characteristic is its brackish nature. Baltic waters are a mixture of marine saltwater waters and fresh ones. If you look at the map, this makes sense. Marine waters from the Atlantic side can only enter through the narrow Danish straits. Rivers and precipitation provide fresh water. There is a saltier environment in the south and gradually pressure environment north and eastwards as a consequence. For life in the Baltic Sea, this implies that quite few marine species can thrive, and their number decreases the pressure the environment gets. We end up with a species-poor sea. If one species is lost, there are few or even no other species that can do the same job in the ecosystems. Moreover, many species are already living at the edge of their salinity range, so any additional stress can be detrimental. As for ocean acidification, the Baltic Sea provides a complex environment. Geological conditions are important. In the southern parts, there is generally more limestones in the bedrock, counteracting acidification to a certain degree compared to conditions elsewhere. Additionally, salinity is important, with the less saline environments being more vulnerable. Moreover, the Baltic Sea is highly impacted by eutrophication, which leads to increased production of algae and plants due to excess nutrients. Whereas eutrophication is a huge environmental problem, it can to some extent slow down the impact of excess CO2 as algae and plants make use of it. The impacts of eutrophication are highly seasonal, and eutrophication increases the pH range that animals and plants are exposed to. There are also a number of other factors that can cause the variability in pH. Animals and plants in the Baltic Sea can consequently be adapted to certain variation in pH condition. An increase in this variability due to ocean acidification is not good news, however. In terms of the question I was asked on the progression of ocean acidification, all this variability has two consequences. Firstly, the reply really depends very much on the region. Secondly, the detection of ocean acidification becomes more complicated. The proper monitoring of ocean acidification is therefore extremely important. Nevertheless, a general answer to the question is that ocean acidification is an emerging threat to the Baltic Sea. Already there are areas where seasonal pH values have dropped due to ocean acidification, and we know of sensitive key species that will suffer if we fail on the Paris Agreement. Thank you.
Thank you, Marco. Very interesting to hear about the complexity of the issues in relation to ocean acidification in the Baltic Ocean. I think that is an area of requiring much further research, to be honest, to pull all of that apart. Okay, thanks for the State of the Nation reports, essentially from the different areas we're talking about around the Nordic seas. I'm moving on to my next question now, and this will be firstly to Richard. Are there climate change feedbacks that may increase the rate and spread of ocean acidification that particularly worry you? Go for it.
It's essentially a review of what's already been said, but on a longer time scale. I think, as Melissa has said, and the Minister, circulation is a very big driver of ocean acidification. We're seeing it, the Pacification of the Western Arctic is predominantly due to an increase in the influx of Pacific water into the Arctic. And there will be, in some areas in this region, significant circulation changes. We've talked about the slowing down of the Atlantic meridional overturning circulation. This has many consequences. One of them is that it actually increases the residence time of the water prior to its removal from the surface, which means that we can guarantee that it will have the maximum load of anthropogenic carbon, the greatest potential for ocean acidification before removal to the deep ocean. The second important one for this region, except for the Northeast Atlantic, is changes in ice cover. You'll see next door, we released just this week the State of the Cryosphere report, and rapid changes in ice cover. Obviously, the first step is that it increases the surface area for CO2 exchange with the surface ocean, so it increases the area, the potential for direct transport into the ocean, but also, has also been discussed, it freshens the ocean. Lowering the salinity, freshening the seawater, reduces the capacity of the ocean to compensate for the CO2 uptake. Therefore, per unit carbon CO2 input, you get a greater pH change. And this is another reason why the Arctic is very sensitive. Related to freshwater, obviously, by definition, is an increased transport of material from land. It's something which is increasingly being studied now as part of the big ocean acidification problem. For the last 20 years, we've been generally talking about IPCC and large-scale trends. But when we look very locally, the contribution of rivers, both with adding fresh water, but as we can see already, a present high CO2 world in the East Siberian Shelf, when you have very close connection, very strong connections between land and ocean, the increasing loss of permafrost, it adds organic carbon, and that, as Helen has explained, the bacteria consume the organic carbon and they release CO2, creating a non-anthropogenic ocean acidification, a direct non-anthropogenic acidification. And as well as that, it also adds organic acids, humic acids and fulvic acids, which contribute to the reduction in buffering capacity. And then, have I gone over time? One more comment is the biological feedbacks. We know from the paleo record, the geological record, we know from the experiments that we've seen that there are very different responses for different phytoplankton types, for example. Some of these very important ones for the carbon cycle are the calcifying phytoplankton coccolithophores, the beautiful blue swirls you see from satellite pictures. These fare very poorly in a high CO2 world. And one of their key roles is removing carbon into the deep ocean. If we lose that, more of the carbon is staying in the deep ocean, a closer connection to the atmosphere, more CO2 staying in the atmosphere. So, is that?
Oh wow!
Is that enough?
Yeah, that'll do to brighten our morning. Those feedbacks are incredible and they're big. I would like to ask Marco if the same question. What are you most worried about in terms of climate feedbacks in the Baltic region that might increase the rate of ocean acidification?
Yes, thank you. It's a very, very good question, and it's known for that lower salinity, which I discussed already earlier, implies higher vulnerability to acidification. And projections of the climate change effects in the Baltic Sea include higher rates of precipitation, at least in certain areas, with more inflow of fresh water, and hence lower salinity. This would certainly be bad news with regards to ocean acidification. Also, this would lead to yet more stress on the animals and plants that are already living on the edge of the salinities they can tolerate.
Okay, thank you. And Melissa, quick feedback from you on this question, please.
Yes, Richard has told the most, but I think it's important to mention that we actually see this the increased CO2 on the Siberian shelves, both from the permafrost melt, but also from ocean uptake, ocean CO2 uptake. And in the Arctic studies from both the Svalbard and also in the outflow waters, where we now start to get a good time series, we actually see this strong enhanced increased ocean acidification caused by meltwater. So glacial meltwater, as on Iceland, for example, and also on Svalbard fjords and everywhere, it really makes a decline in pH and carbonate ions, which is much stronger and faster than the anthropogenic CO2 itself. So we have all these other processes that are affecting and in stronger magnitude in a way.
Okay, thank you, Melissa. Lots of food for thought there. My next question is, will ocean acidification impact marine ecosystems, biodiversity, fisheries, aquaculture, and if so, and can you give examples? To Natalia, please.
Yeah, thank you for the question, Carol. So we know that fjord basin water, when it isn't renewed for several years, it does become undersaturated with respect to aragonite, and even in certain cases with respect to calcite. And these conditions, as other speakers have alluded to, can make it more difficult for calcifying organisms, and that is organisms with hard structures like corals or certain shellfish to build those hard structures. We don't know yet how acidification will affect deep sea communities in the fjords, But we do know that certain fjords have deep sea coral reefs, and of course those species may be vulnerable to acidification trends in those fjords. We're also working now with partners at the Institute of Marine Research to assess coastal risk for economically important shrimp habitats as part of a new project. So hopefully in the future we'll have a clear answer for you on this question, but it is currently a knowledge gap.
Thank you very much, Natalia. Lots of questions, really. Yeah, Marco, the same one to you.
Yes, thank you. I would, from a Baltic perspective, definitely answer with a yes on that question. And I would like to point out once again towards the fact that this is a foreign species and towards the serious consequences of losing species that have a certain function. And an example then would be a small clam called the Baltic tellin. It's highly numerous among the relatively few species living in the sea bottom of the Baltic. And it has many important ecosystem functions, both as a consumer and as a source for food for predators. And another example would be the consequence for cod fisheries. Models have suggested for the Western Baltic Sea even a 90% decrease in recruitment for cod.
Oh, thank you, Marco. And then, Melissa, what are your thoughts about the impacts on marine ecosystems, biodiversity, fisheries, etc.?
Yeah, I want, because I think both Natalia and Marco has mentioned most of the direct on the bioorganism level, but I think that we haven't really looked into the effect of ocean acidification on other chemical processes. We're not really thinking about them. So you could, for example, have a change in the connection between the organic matter and metals. So it could also be bioavailable trace metals that are important micronutrients for organisms, or it could also be toxic metals like mercury, for example. So then how they complex bound to organic matter will depend on the release of these compounds in the water and then the uptake to the organism. So I think that is one under-investigated thing, that we are not really investigating the change and the effect on other chemical processes in the ocean.
It's very useful information on research gaps there. Very good. Helen?
So just to highlight really that just like humans, pH is needed, and a stable internal pH is needed in our body fluids. So actually any marine organism also needs to keep a stable pH physiology. So there's the potential to impact many different organisms, not just the calcifying species. And I think it's important to remember that as we go forward, that the physiology, both in terms of pH and the CO2 that's going to increase in the seawater, can have impacts depending on the species' ability to buffer their internal change and monitor their internal physiology. And we're particularly concerned about early life stages, and if species can't have their early life stages go through to adults, then there's no adults to be there in the first place. So a lot of the work that we've been looking at has been focusing on the early life stages and the non-calcifying species, but also as early life stages, often they don't have proper shells formed to some of these calcifying species, and that's when they're potentially most at risk to some of these issues with ocean acidification.
Thank you, Helen. Helen, if you can stay there. The next question I'll ask to you first. What is the role of long-term ocean observations, and how does this help?
So ocean observations, and particularly long-term ones, are fundamental for us to provide the data that can then provide evidence to support any changes. It allows us not only to see what's going on, know where the rates of ocean acidification are happening most rapidly, know where perhaps ocean acidification isn't such a big issue, but look at all the different areas and be able to say what's going on in terms of ocean change. So long-term measurements are needed in order to take out the natural variability and the other factors that are going on that can influence the chemistry on short time scales, so that we can actually see these long-term trends and long-term changes. But also it's not only important for seeing what's going on and what has been going on, but also to provide evidence to management strategies and to then know whether those strategies are actually being implemented correctly and actually having the impact that we want them to have, and being able to look at whether that change has made a difference to the ocean. So we need to be able to look at the multitude of stresses and impacts that are going on and tease apart those and be able to use that. So we need good data, good observations to be able to do that sufficiently.
Thank you, Helen. Melissa?
Yes, I greatly agree with Helen, and I just want to emphasize also that the reason we know that we can observe ocean acidification occurring now is actually that we installed open ocean surface buoys or to measure CO2. And that was not, the reason was not to investigate ocean acidification, because we didn't talk about that at that time in the 90s. It was, we were looking for the missing link of the anthropogenic CO2. So it was, we were looking for what is the ocean's role of the CO2 uptake. And that is the reason, those data that we have collected since then in some of the ocean stations is the reason for that is so now we can actually observe ocean acidification. Otherwise we wouldn't have been able to do it. It's the same with the air temperature and the climate long time series you have on the ocean temperature as well. We wouldn't know it was happening and we couldn't prove it. So of course it's super important. And I also want to add that the ocean CO2 society or we are really struggling on funding of these things. So they are mainly short-term, very chaotic funding, and that we need to have for the Arctic, a pan-Arctic concerted effort on long-time observation, and we need sustained funding to do that. So.
Well, I think we'll all agree with that. And Richard, your thoughts, please.
I agree with Melissa, not obviously on the funding. All researchers want more money, so I support that very much. But I do think as well, something you said very early on, that we started, I'm not saying Petter is older than me, but Petter started a few years before me, but I started a long time ago as well, and it was purely to monitor CO2 in the ocean. And those observational time series that we have been driven to answer that question, very much coupled to physics, very much coupled to circulation. And there's a disparity now between the data sets that we have and the SDG needs and the societal needs that we have already. Most of the time series stations, the ships of opportunity, are not targeted to answer the societal questions that we have today. So this is a plea not for funding for me, but funding for local and regional managers and regulatory bodies to be able to understand their particular system, their particular service, and design observational ocean acidification time series around those critical services.
And if I can add, is also to build capacity for those people to measure and control their data locally.
Absolutely.
So it's not carried out by, some highfalutin scientist, flying in, measuring it, but, give the power to the people, that's what I say.
Come to
Peter,
tomorrow.
Peter, I wonder if you could add your thoughts on this.
Of course, agree with what has been said. Yeah. Can you hear me? I guess I agree with all that has been said. I'd just like to point out in this context that the Sustainable Development Goals, SDG 14.3, actually addresses to minimize and address the impacts of ocean acidification, including through enhanced scientific cooperation at all levels. So there is a hook there for actually doing these efforts in a good way. And I think several of the people here who are involved in the Goa On network and doing this and delivering data for ocean acidification as the indicator of this SDG is doing a very important job. The calibration and the comparability of these observations, it wasn't like that. I think Melissa pointed to it, it's a couple of decades ago, they weren't comparable. And it's extremely important to have that high quality when you deal with the science policy interface. And then, of course, we also need observations and actions to mitigate this, which is more difficult. But the basis is these long-term observations, and they should be comparable. They should be suitable to also address the impacts, not only demonstrate the ongoing acidification. So that's a challenge for the development of the observing system too in the future. Thank you.
Thank you, and thank you for mentioning SDG 14.1. And I think the hubs, the GOAN hubs here are certainly contributing to that via the Global Ocean Acidification Observing Network body, and it has a program called OARS, which is also contributing to the Ocean Decade and SDG 14.1. So it's this massive community of scientists all around the world that collaborate through hubs that are helping to achieve this. But they're all doing it on little bits of money here and there. It sounds great, but it's totally underfunded. Anyway, moving from funding and observations, Emma, you've heard from the experts. Are you concerned about ocean acidification now that you've heard from the experts?
Definitely, I would say, but I've also been concerned about the ocean for a long while. I think something it's very, very underrepresented in politics and policy overall. And as Carol stated, I study nature management in Denmark that is surrounded by coast, but we don't get taught anything about ocean habitats or ocean restoration. So I feel there's a quite big disconnect when talking about climate and nature to ocean. And overall, that is just something that I feel it worries me a lot, because why would somebody like me who can go in and make policies and help doing different kind of management, and I know nothing about oceans? Like, it makes no sense to me when it's such a big part of this globe. So I am worried, and there's so many complex issues with the ocean because it's so dynamic. So acidification is just one of many issues, but it's a huge issue.
Thank you. Thank you. And what do you think you could do to act on what you've just heard about as an individual?
Well, I think one of the big issues with oceans is that it's very hard to communicate the complex structures and things that happen in it. Like, it's easier to look at a forest and see, oh, we'll fell the trees, that's a problem. And it's easier to explain the carbon circulation and so on in this. So I think the big issue with oceans and ocean acidification that I would like to do is to talk more about it, just to be better at informing and communicating. Because even for me, who I have a natural science background, it was a bit hard to follow what you guys were saying because there's so many abbreviations and so much chemistry in it. So I want to be a part of solving that issue of communicating it better so people become aware of it, because that's the biggest issue right now. Not a lot of people are aware of it and like the consequences it can have.
I wonder if the Minister for Education from Denmark might be the person to speak to as in terms of the curriculum.
I think it's both that, but also because that the researchers in Denmark and the Marine Institute as well have a hard issue getting funding. Okay. It's the same, like it's so easy to get funding for trees and for agricultural studies, but really hard for that area.
Thank you, Emma. And thank you for your sympathy and empathy. Now, I know you want to ask a question.
Yeah, I really want to ask you guys, why do you think that ocean acidification is such an issue that's not that big of awareness about? Why do you think it's so underrepresented when we talk about climate and policy and politics? Why don't we speak about ocean acidification and oceans as much? I know you're all very deeply passionate about it, so it's probably harder for you to understand why other people wouldn't do it. But why do you think it's an issue in the public space? Like, why is it underrepresented?
Could we turn to the Minister first? You're on a small island surrounded by a big ocean, a large island state, essentially, a large sea state, island sea state. So please give your thoughts on that.
Yeah, well, let me first thank all of you for a very insightful discussion. But I really like your question, Emma, and I think I think the main reason is because ocean acidification is sort of silent. We don't really see the impacts that well. Yes, we can study it and we can report on that it is bad for certain organisms in the oceans that can actually escalate up the food chain, etc., etc. But at the end of the day, I think we are simply more moved by polar bears disappearing, charismatic fauna in particular. And I remember when I was studying for some 15 years ago, I studied environmental science, and I remember that we had a paper that was investigating the funding for conservation. And there was a correlation between I'm going to put it very simple, the cuteness of the species that was being investigated or researched, and the money that's particular or those projects were actually getting. And that I found really interesting. And I think this is part of the problem, that we somehow need to have more empathy and love for the oceans. How can we do that? That's another question, and maybe I should not talk here for the whole time, but I think that this is a really an area where we can do so much better.
Okay, thank you, Minister. We've got 3 minutes left, so I'm moving to the final question. If there was one single outcome for the ocean that you would like from COP26, what would it be? Minister, I'm asking everyone to just give a 30-second wish for the ocean. What's the best ocean outcome from COP26? Minister?
You know, this is very difficult for politicians, but I'll do my best. My message is simply to cut emissions, and to deliver on the promise of the Paris Agreement. That is my message.
Thank you. Could I go to Peter next, please?
Yes, we need to change our relationship with the ocean in line with what has been said. We are land animals. We need to understand the ocean. We need to spread the word. Join the high-level panel for a sustainable ocean economy, which had a side meeting at this COP event with more governments joining. We rely on the ocean, and the ocean is not only a victim of climate change, it's also a host of solutions to climate change. And I think that's a message that will help us get more attention to the ocean if we can get that too. Thank you.
Thank you. Melissa, 30 seconds. Your wish, please.
Cut emissions, of course, but we should also remember that we should learn from this pandemic. I think that we humans, we can actually change, because we need to discuss this in a larger context. How can we cut emissions, and that we actually can do it and not lose hope, because we can change, we are adaptive, and we saw that very clearly during the COVID. So I think we should be inspired by that, and we also need to think about climate justice, but that's not my expertise. But we can change. And I think that's the main message.
Great. And Natalia.
Yeah, thanks. I'm just going to echo the minister and say we need ambitious climate action to rapidly reduce emissions, but we also need to formalize how the ocean is considered under the UNFCCC framework. And it's really important that there's dedicated funding for continued ocean observations, and that includes for the deep ocean, where we have really large observation gaps.
Marco, 30 seconds, your wish, please.
Yes, thank you. So we already know from different IPCC reports that even 1.5 degrees is devastating for some marine ecosystems, such as warm water coral reefs. So I would just have the plea that please do not make it any worse than that. Thank you.
Thank you. Emma?
Oh, that's a hard question. For one, I want justice and loss and damage and funding for it. But I think overall it is cutting emission and getting this toolbox and the rule book for the Paris Agreement down, so we can actually move forward and not keep discussing the old deal.
Richard?
Yes, I agree to cut emissions and to bear in mind or to take account of even the Paris Agreement is too much for most of the systems we've been talking about today. The decrease in pH that will happen through the Paris Agreement, hopefully, will take 50 to 70,000 years to return back to normal. You can't clean CO2 from the ocean. So these changes are massive and permanent.
Helen?
So I agree, reduce emissions, but I'm also going to say I'd like to see the continued discussion and dialogue of oceans maintained after this COP. So it would be really nice. There's been a lot of media attention, there's been a lot of discussions, it's been picked up in negotiations in the past, hopefully will continue for this one, but it would be really nice to see that continued and not just dropped after this COP. It would be really nice to get education, to improve communication, to have a kind of better strategy for making oceans as part of our lives as much as possible.
Thank you. I agree with all of those. So I'm going to have all those wishes, as well as one more for myself, and that would be to include the oceans, which cut across all the UNFCCC pillars. I want an ocean in the ocean actually in all of those, because the ocean naturally cuts across. It cuts across energy, climate, ambition, funding, mitigation, transport. It cuts across everything, the food sector, every single thing. So in order to make sure the ocean is part of the global stocktake in the future, I think the UNFCCC should adopt the WMO Global Indicators of Climate Change, which includes 4 that are in the ocean: sea ice loss, ocean warming, ocean acidification, and
Deoxygenation.
sea level rise,
Sea level
of course.
sea level rise.
If that's in the global stocktake, the nations will have to look at it, will have to measure it. It's a one way of really bringing the local aspects up. So I have to wrap up now. So many, many thanks to our panelists, the virtual ones that have just disappeared, and to the panelists here, and for everyone who's listened to us, and tweet away. Thank you very much, everyone.
Okay.